Hi, welcome to this video on cells and batteries. So I'm going to jump straight into it and say, what can you expect from this video? Well, you'll learn the difference between a cell and a battery. This is not super complicated. We'll kind of a singular assembly we'd call a cell, and when we put two cells together, for example, we call that a battery. But we will go into that in a little bit more detail in a slide or two. We'll also understand, or rather explain the relationship between reactivity series. We have done videos on, or a video on the reactivity series on this channel before. So now the reactivity series also plays a role in predicting the relative voltage or potential of these electrochemical cells. We'll also explain that today as well. And we'll also give you some examples of rechargeable and non-rechargeable batteries. So if you've got a gasoline car or a petrol-driven car, then when you first turn that ignition, the battery turning the engine over is a lead-acid battery, and that's an example of a rechargeable battery. And then if you've got kind of devices around the house that take what they call AA or AAA batteries, then those are often non-rechargeable. So you are very familiar with non-rechargeable batteries, and we'll also talk about maybe some lithium-ion batteries in your mobile phone as well. So first of all, an electrochemical cell. So if I take an electrolyte solution and I place two different metals in it, now sometimes people call this dissimilar metals. It's a sort of fancy way of saying different metals. If I put those two metals within a electrolyte, and I make an electrical contact between those two metals, then a voltage or a potential is generated in the units of voltage, and a current can flow. Now, what's actually happening is we've got the magnesium in this particular case essentially passing electrons to the copper. So the magnesium is being oxidized. So we got magnesium going to, or magnesium metal going to magnesium 2+, and it's releasing electrons. And then in the solution, we've got copper ions, which then are reacting with the electrons and actually giving us copper metal. So we call that the cathode. Now, an electrochemical cell is that simplest construction where you've just got two different metals in an electrolyte solution. Now, if we want to predict the potential in the units of voltage of that particular cell, then we've previously done a video on reactivity series, so you can find that on this channel as well. But in the reactivity series, we generally have a sort of table of the different metals, with most reactive at the top. We may have magnesium, aluminium, zinc, tin, lead, and at the bottom, least reactive being copper. So if we put magnesium and copper together, for example, they're quite separate from one another, one at the top and one at the bottom of this particular table. And that sort of separation means that you can predict that they'll give one of the larger voltages when combined together in an electrochemical cell like this. Now, if we instead don't use copper, but instead we replace it with zinc, zinc is fairly reactive, but it's actually closer to magnesium. So in fact, there's a less of a difference between magnesium and zinc. And in fact, the potential generated by such an electrochemical cell in the units of voltage will actually be smaller. So copper and magnesium will give a larger potential in units of voltage than magnesium and zinc. Now, a battery is really simple to define. If we've got two electrodes, for example, magnesium and zinc, in an electrolyte just simply together, then that's an electrochemical cell. But if we put one electrochemical cell next to another electrochemical cell and connect these in series, then what we have then is a battery. Now here I've shown that the voltage has effectively gone, with the electrochemical cell it was 1.5 volts. When we put two cells together in series, then I've sort of made it 3 volts. It will probably be less than, but theoretically it would be 3 volts. So two or more cells in series is the definition of a battery. But of course a battery can have lots and lots of cells. So if we put 3 of them together, we may end up with a battery, in this particular case 3 cells in series generating 4.5 volts. So a battery is just 2 or more cells wired together in series. Now, you are familiar with non-rechargeable batteries and cells. So for example, you will have batteries that look like this. They'll be in the drawer in the house somewhere, and you'll put them into devices, and they'll run that device for a while, and when they go flat or run out of charge, unfortunately you have to dispose of them. But you'll also be quite used to lead-acid batteries. Now, this is obviously, people are getting, we're all going electric vehicles these days, so in fact lead-acid batteries in cars are diminishing. But if you have a gas petrol-driven car, a gasoline or a petrol-driven car, then there is actually a lead-acid battery in there, and that's for initially turning the engine. So when you turn the ignition, you're actually engaged in the lead-acid battery, which is just about enough power to turn over the engine and get the engines essentially started. So that is rechargeable. It's recharging as the car drives along. Now you are very familiar with lithium-ion batteries. As I said previously, we're all going on to electrical vehicles these days, so they're all mostly driven by lithium-ion batteries, but also in your pocket or near you. You've probably got a cell phone near you. You obviously recharge it, and inside there is a lithium-ion battery inside that cell phone as well. So if I was to summarize what we've done so far is we now know the difference between a cell and a battery, two different metals in an electrolyte that constitutes a cell. If I put two or more cells together, that constitutes a battery. So it's not too hard to understand the difference between a cell and a battery. Understand that there's a reactivity series, and when we combine two metals, for example, that are quite at different ends of this table, magnesium and copper, we'll get a large voltage. And if we combine two metals that are closer together in this reactivity series, like zinc and magnesium, then we get less potential in the units of voltage. And then you do know the difference between chargeable and rechargeable. Non-rechargeable are those batteries that you'll put into sort of small appliances around the house, but you can't then reuse them, whereas every time you plug your phone in, your smart device in, and it's recharging, then obviously you've got a lithium-ion battery in there, which is an example of a rechargeable battery. Now, if you have any questions, I would always say don't hesitate to reach out to us at ZP. Okay, thanks very much.